says suppose per capita income is 38,000, population is 440,000 people, and percent elderly is 30%. Further, suppose that the per unit cost is constant at $10. It wants us to calculate the profit maximizing price, assuming that all these point estimates in the table are correct. Well, we know that we can estimate quantity using this regression. In this example, the price variable is not given to us. So we plug in all of our components and we see that we have a demand function. So price is a variable. And the demand function is Q equals 209.075 minus 7p. Well, now that we have solved for a demand curve, we can solve for the profit maximizing price since we know that marginal cost is equal to $10. So this goes back to earlier sections in the class, solving for the profit maximizing price. What does that mean? We're going to maximize profit. So starting from the profit function, we're going to take the derivative and set it equal to 0. We want to write profit in this form, price minus marginal cost times quantity. When we take the derivative of the profit function with respect to price, we're going to use the product rule, which says first times the derivative of second plus second times the derivative of first. So let's take that first part. First, price minus 10 times the derivative of the second thing. The second thing is 209.075 minus 7p. So the derivative of that is just minus 7. Plus second times derivative of first, where second we just stated, and the derivative of the first thing is price minus 10. And the derivative of that is just 1 because the coefficient on the p variable is just 1. Now we can distribute through that negative 7 to our first thing and get negative 7p plus 70 because it's negative 10 times negative 7. And now we're ready to combine like terms and solve. We can add 14p to each side and now divide through by 14 and we find that our price is equal to 19.93. What is the upper control limit for a 95% confidence interval for the quantity demanded? Well, we know that price is just a function of quantity, so first we have to solve for quantity. Well, we have already solved for price. We can plug in price and see that our quantity is equal to 69.54. Using our rule of thumb, if we're trying to make a 95% confidence interval, we're going to multiply the root mean squared error by 2. And in this case, the root mean square error is 16. So to find the upper control limit, we would say 69.54, which is our quantity, plus 2 times that root mean squared error gives us an upper control limit of 101.54.